how do you do your agent fine-tuning? There are a bunch of fine-tuning datasets, but you have your own internal APIs or your internal tools that you have built. You could create datasets that are similar in format to the ones that are present in any of these papers. You can see there are more than 150 papers related to tool use and tool fine-tuning. You can choose any of these. These are the ones. AgentFlan is something that I would recommend looking at. That is one part of the equation. Something that we internally used and works well for us is the tool call is something like this, and it includes torch, upload, etc. But what we do is we create this AST of our entire tool library, and then we do AST matching to see that this matches a subset of this, so that we see that this is a valid tool call. It's one of the verification methods. The other thing that I think is pretty important and it's ignored is, you saw the diagram earlier where you are selecting a tool to call and then you are invoking the tool. But the bigger question there is, when do you know that you should select and invoke a tool? In an ideal scenario, you should have like interleave generation where you are generating something and you can say, I need some data, let me go and fetch it. And then you generate more, and then we can say, at this point, I need to stop. I need to go and fetch something from my tool, and so on. The model needs to know when exactly to call a tool versus when to not. Tool calling is expensive because it adds to your latency. If you look at this diagram, there are things that you know that this particular LLM that you're using has that capability to. For example, if it is 5 plus 3, you better let the model do that rather than invoking a calculator to get the answer. On the other hand, there are unknowns where you know that the model would not, for example, if it is some knowledge that you know that the model has not been pre-trained on, you know that a tool call is definitely necessary. On the other hand, there is this boundary, there is this part here where you're not sure. And for that, you can use estimation methods. One of the estimation methods is self-consistency. You ask certain queries, you find if the model is getting over multiple generations, if it's getting consistent answers. If it is, then it's confident and it's correct, then you can put it in the known bracket and so on. Or it's absolute where you have the ground truth. Once you've found this, once you have a clear-cut boundary, what you can do is you can fine-tune your model such that for tasks where the confidence level is high, you can fine-tune it such that the instruction there, the output is like this. So in the fine-tuning data set, for confident tasks, you can say, sure, I'm confident in the answer. And for non-confident tasks, it would say, I'm not sure, so I'll use mathematical tools. And you train the model this way. Or you can do it. So we do it in the implicit way, but there's also an explicit manner where you actually say my confidence estimation is 60%. And then during inference, it gives you like a confidence estimate. And then if the confidence estimate is greater than something, it uses the model. Otherwise, it starts calling tools. I think this one is a little risky because it's not exactly calibrated. The 60%, it's hard to get that bounded in a number and so on. So